Hello guys, welcome back to the quantity surveying workshop and to another video. In today's video, we are going to be treating how to build up rates for the removal of excavated materials or surplus excavated materials from sites and was depositing it in spoiled heaps a fair distance away from the site. So in this example, we are considering that we are using wheelbarrows to dispose these excavated materials to the disposal sites where they will be turned into spoiled heaps. So without any further ado, let's get into the video. So the bill of quantity extract states: remove surplus excavated material from sites and deposit in spoiled heaps average 40 meters from site, and the volume to be excavated was 65 meter cube. So it means that the 65 meter cube volume that has been excavated, we have to remove it from the site 40 meters away in spoiled heaps. So now you now ask yourself, how do we go about this operation? Since we are going to be using unskilled labor to carry out this operation, we will now ask ourselves, since we are using a wheelbarrow, we have to determine what is the labor constant that it will take the laborer to excavate a certain amount into the wheelbarrow that will take the capacity of the wheelbarrow, and then the time he will drive this wheelbarrow 40 meters away from the site and then dispose this excavated material, which is the capacity of the wheelbarrow, into the spoiled heaps and then return. I hope you get what I'm saying. So after you've gotten the labor constant, you now have to also determine what is the capacity of the wheelbarrow. So those are the two important things you have to determine. So we're going to be making assumptions that the labor constant, or the time it will take the laborer to carry out all this operation, is 1.75 hours. And the capacity of this wheelbarrow is 0.2 meter cube. So it means that the capacity or the volume of excavated soil which can enter into the wheelbarrow is 0.2 meter cube. So with those two parameters, we can now start building up our rate. So the first thing now we have to do is this: since it will take the laborer 1.75 hours to load the wheelbarrow, take the wheelbarrow 40 meters away, deposit the excavated material on the wheelbarrow to spoiled heaps, and then return, it will take him 1.75 hours. So we can now say for every time that he excavates into the wheelbarrow the capacity of 0.2 meter cube, which is the capacity of the wheelbarrow, we need to know how many times he will go and come back until he finishes the 65 meter cube of excavated materials that he is expected to dispose. I hope you are getting me. So in order to do that, since we know the capacity of the wheelbarrow and we know the total amount of excavation we have to dispose, if we divide the total amount of excavation we have to dispose by the capacity of the wheelbarrow, it will tell us how many times we are to excavate excavated material into that wheelbarrow. Because it's normal logic, the capacity of the wheelbarrow can only take 0.2 meter cube of soil. So how many times we will put 0.2 meter cube of soil until we've finished the 65 meter cube that we are expected to excavate? So that is what we are looking for now. So we will now say, consider man hour as 1.75 hours. Take wheelbarrow capacity as what? 0.20 meter cube, as it has what been given. So now, since we know our total volume is 65 meter cube, we can now determine our number of tons. That is how many times the wheelbarrow will go and come back. So we can now say number of tons So we can now say the total number of tons is equal to the total volume we are expected to excavate divided by what? The capacity of the wheelbarrow, which is 65 meter cube divided by what? 0.2 meter cube, and that is going to give us what? 325 tons. So it means that the laborer is going to what? Excavate 0.20 cubic meter or 0.20 volume of soil into the wheelbarrow 325 times before he can what? Completely dispose this 65 meter cube. So that is what it means. So since we know the number of tons, we can now determine the time it will take him to what? Accomplish this 325 tons. So since we know that 1 ton will take 1.75 man hour, so we can now say the total man hour will now be equals to what? 325 tons multiplied by what? 1.75 hours, and that will be equals to what? 568.75 hours. .75 hours. So we can now see if the cost of labor per hour is equal to 625 naira per hour, so what will now be the cost for what? The total time it will take them to what? Carry out this operation. You will now say cost for 568.74 will now be what? Will now be equals to what? 625 multiplied by what? 568.75, and that will give me what? 355,468.75. So after doing this, now we will now add our what? 25% profit and overhead. So 25% profit and overhead of this price will now be what? 88,867.18. So you add everything together, and that will give us 444,335.94. So this is the cost it will take us to what? Excavate what? 65 meter cube, but we need to determine the cost of 1 meter cube because that's the standard of our what? Estimation. Therefore, cost per 1 meter cube of excavation will not be equal to what? D is divided by what? The total volume. had to give us 6,835.94. So this would be your cost per meter cube, and then you can now take it towards your bill of quantity to determine what your amount will be. So we've come to the end of today's video, guys. I hope you derived adequate utility from it. If you derived any information, please do not forget to like, share and subscribe to this channel because it helps the channel grow. Thank you, and we'll see you in the next video.